All right, let's get going. This is Uncle Fonzo again. Welcome to all my nieces and nephews on planet Earth and other nibblings. Let's see here. Let's get things continuing with. I think we are on tuples now, right? Because last one we did was optionals. Now we're on tuples. Yeah, so continuing with the learning TypeScript series here. So we're watching Jack's videos. Give him a like. Yeah, continuing down the road here. We're on video 7. We've got a long road ahead of us. Video 7 of 44. So, tuples. Let's get to it.
BSTS episode 6. In this one, we're going to look at the oddly named tuples, define what they are, and then show how to implement on them and show some common implementations that you might see out there in the wild. All right, let's get right into it. So the first thing I'm going to do is create another file called tuples. And I'm going to make what most people would consider the kind of canonical tuple, at least in the documentation, and that is a 3D coordinate. So I'm going to define a type.
Pause here for a second. I just got lost in my sidebar just that quick. Let's get over here now. Let's get up here. There we go. Create. Hit create. Oh, we're in the wrong mode. Create. Create file. Okay, tuples, right? Tuples. Yeah, tuples.ts, right? Is that what you got, Jack?
Of 3D coordinate.
Yeah, okay, tuples.ts, sorry. TS, excuse me. Yeah, we go to that. Need basics, close that one out. Don't need optionals, close that one out. Stay in tuples. Okay.
And then I'm going to define this as a tuple. And a tuple is an array. So I'm going to start with an array, and then each value in there is given a name and a type. So X is going to be a number, Y is going to be a number, and then Z is going to be a number. So in this case, all of them are the same number, but in tuples, each particular item in that array can be any type you want, and we'll see that in just a second. Okay, so let's actually implement on this and show you how it works. So I'm going to create a file.
Hang on, let's make this. Let's get that going. Let's see. Array. Number type. Type Z is a number. Okay. All right. I guess we can close the side there. Okay. All right.
Function that adds two 3D coordinates together. So it's going to take C1, which would be a 3D coordinate, and then C2, which is also a 3D coordinate, and then it's going to return a 3D coordinate. And with that, I'm just going to take C1 at 0 and add it to C2 at 0. Copy and paste that 2 more times. Change this to a 1, that to a 2, this to a 1, that to a 2, and we should be good. So let's console that out and give it a try.
All right, let's get that going. Oops. Keep forgetting that I am in vim mode for some reason. I don't know, maybe I need some coffee. Get my brain started again. Okay. Coordinate. Right. Coordinate 2. Be 3 coordinate. So that is that. Okay, interesting. C1, 3 coordinate, C2, 3 coordinate. Okay, so that function ends, that's going to return to us the 3 coordinate type. Let's see. Return. Let's see. 1. Let's get that going again. Let's see. I got C and we got C2 of 0, comma C1, and we got a little plus, and we got C2 of 1. Let's see. C1 of 2 and coordinate 2 of 2. All right, great.
And we just specify it using
Of course,
an array. So let's say 0, 0, 0, and add it to 10, 20, 30. See how that goes.
Oh, Prettier did the same thing to him too. Okay, great. Do we need to put a comma after that? No, let's do that, and then bring console.log add. Oh, nice. Okay, so interesting. But it would be neat if somehow that. Okay, we'll figure that out. Interesting later on. But add chords to 0, 0, 0. Okay, first one, and then next chord will be 10, 20, 30. Okay. We're missing something. What are we missing? Yeah, he's got another. Okay, wait, we're missing another thingamabob here. There we go. Okay, there we go.
All right. Let's do npx ts node and then do tuples. See how we go. All right, 10, 20, 30. Let's make sure we got the right order. So just change out that origin point or whatever. Yeah, looking pretty good. Okay, great.
Okay. 100. Okay, hang on. We're going to do the same thing. Oops, wait. Sorry. Oh, there we go. Now we get that going. And we'll say npx ts node tuples run that. Okay, groovy. Then we went back and changed this to 100. Wait, change that. Keep forgetting. This to 100. All right. Here and again. Okay. Oh, file wasn't saved. Excuse me. Okay. Okay. Now, why change that to 100? Just scooch back a bit.
Let's do npx ts node and then do tuples. See how we go. All right, 10, 20, 30. Let's make sure we got the right order. So just change out that origin point or whatever. Yeah, looking pretty good. Okay, great. But if you're a React engineer, you actually probably deal with one particular tuple all the time, and that's the useState tuple. So useState returns a state and then a state setter. Let's go and implement our own simple string state that does something similar. Okay. So it's going to take an initial value, which is a string, and then it's going to return a tuple. And that tuple is going to have first an accessor. In this case, we're going to use a function, and that's going to return a string. And then we're going to have a setter. So that'll take a string and return void. Looking pretty good so far. So let's create a variable for our state. And then give it the initial value. And then I'm going to return an array. And that array is going to have a function in it. The first one returns that string. And the second one takes a string and then sets the string value to that incoming string. And just like before in previous videos, this is a closure. So what's going to happen here is we're going to capture the initial state of the string, and then as we change it, it's going to be tracked. So it's basically a piece of stored state. Okay, so now let's use this. So we want a string 1 getter and a string 1 setter. And that's going to come out of simple string state. And then I'm going to give it the initial value of hello. And let's just console log the output of string 1 getter. And then use string 1 setter. To set it, we can see that we're hinted that v is a string. So we're going to say goodbye. And then call that again just to make sure that we're getting the right value. Let's try this out one more time. There we go. String with
So we're getting into
log
some stuff.
set a status videos,
I'm in my head.
and that's going to return a string. And then we're going to have a setter. So in smaller. Use state looking pretty good. Okay, great. But if you're a React engineer, you actually probably deal with one particular.
Let's see. Note. Tuple. Let's see. So now we're going to do tuples with different types. Okay. Oops.
Particular tuple all the time, and that's the use state tuple. So use state returns a state and then a state setter. Let's go and implement our own simple string state that does something similar. So it's going to take an initial value, which is a string, and then it's going to return a tuple. And that tuple is going to have first an accessor.
Simple string state. Initial string.
In this case, we're going to use a function, and that's going to return a string. And then we're going to have a setter. So that'll take a string and return void. Looking pretty good so far. So let's create a variable for our state.
Oh, interesting. What the frack? Wait, did I just type all that? Wait a minute. Let's go back. Okay, wait a minute. Initial, hang on. Initial string. Initial string of that. Right. Right. Equals. Right. String. Right. Okay. Boy, I must really need some coffee. My brain is just like another arrow. The function returns void. Okay, so we're looking at squiggly. There you go. Okay. So initial. Boy, oh boy. Initial string. Hmm. Oops. String. Da, 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 da. Okay. All right.
Successor, and then it's going to return. Well,
Start again.
so it's going to take an initial value,
I need to get some coffee, man. I guess
which is a string, and then it's
right
going to return a tuple. And that tuple is going to have first an accessor. In this case, we're going to use a function, and that's going to return a string. And then we're going to have a setter. So that'll take a string and return void.
Getter and setter. Okay.
Looking pretty good so far. So let's create a variable for our state.
Setter. All right, cool. Okay, what did this?
And then give it the initial value. And then I'm going to return an array. And that array is going to have a function in it. The first one returns that string. And the second one takes a string and then sets the string value to that incoming string. And just like before.
Okay, now we're going to pause you for a second. I need to actually absorb what's being said here. Str. String. Okay. B plus string. What is function? All right, great. Str equals V. Right. Yeah, I don't like that it did that. That was do that. Like stop moving my stuff around without asking me. Okay, that's the structure I want. String initial, return. Let's get that arrow function to look more like an arrow function with a little space there. For me, right? To me, to my eyes. All right, so now watch me click out of here and prettier will rearrange everything. Okay, man.
Or in previous videos, this is a closure. So what's going to happen here is we're going to capture the initial state of the string, and then as we change it, it's going to be tracked. So it's basically a piece of stored state. Okay, so now.
Oh, wait, so this is different types. List nesting exceeds Mac lips. Okay, well, I don't know what's going on with that. Okay, here. Closure. Ah, how do you spell closure? Closure. Closure. Oh my god. Thank you. Closure. Okay. Closure. There we go. Closure. Right. Okay.
So now let's use this. So we want a string 1 getter and a string 1 setter. And that's going to come out of simple string state. And then I'm going to give it the initial value of hello. And let's just console log the output of string 1 getter. And then use string 1 setter to set it. We can see that we're hinted that.
Great. So aggravating. It's, yeah, like it would be neat if I could tap into it, but okay, we gotta figure out how to deal this with that. How to fix that. String state, get a setter. All right.
that V is a string. So we're going to say goodbye. And then call that again just to make sure that we're
that. Mm. String one setter. Okay, wait, getter both string one getter, string one setter, string one getter. Okay, wait, spell. Let's see. Okay. Getter setter. Okay, there we go.
we're getting the right value. Let's try this out one more time. There we go. Started off as hello and became goodbye. Awesome. And just to show you that this is a unique piece of state, let's go and create a different one. And we'll call this one string 2 getter and setter. And we'll make that Jack. And then we'll console log that to start. And then console log that again at the end. And you'll see that there's no difference, right? So we don't actually set string setter 2. And so it's still going to retain the same value as it had when we initially called that function. Okay, so now you know that a tuple is an array, and each one of the elements in the array can be named and have different types. In the next one, we're going to look at my favorite part of TypeScript, and that's generics. And I think that's when you start to see the real power of TypeScript. Can't wait to see you there. Of course, in the meantime, if you like this video, please like and share it with your friends. And of course...
Okay, did we understand? Okay, so that's tuples with different types. Tuples with different types. This is like, what am I looking at? Single string state, initial string. I just don't like the way it looks on the screen, right? I wish I could tell prettier to like calm the frac down and leave that alone. Initial string. Right. Okay, and returns an array, getter and setter. Function string. What's V and what's V? Void? It's V. I don't like single letter or anything. What is V? Go back. I don't like the single letter thing. Like, what am I looking at here? Let's go back up to that. That's cool.
that does something similar. So it's going to take an initial value, which is a string, and then it's going to return a tuple. And that tuple is going to have first an accessor. In this case, we're going to use a function, and that's going to return a string. And then we're going to have a setter. So that'll take a string and return void. Looking pretty good so far. So let's create a variable for our state. And then give it the initial value. And then I'm going to return an array. And that array is going to have a function in it. The first one returns that string. And the second one takes a string and then sets the string value to that incoming string. And just like before in previous videos, this is a closure. So what's going to happen here is we're going to capture the initial state of the string, and then as we change it, it's going to be tracked. So it's basically a piece of stored state. Okay, so now let's use this. So we want a string 1 getter and a string 1 setter. And that's going to come out of simple string state. And then I'm going to give it the initial value of hello. And let's just console log the output of string one getter, and then use string one setter to set it. We can see that we're hinted that v is a string. So we're going to say goodbye, and then call that again just to make sure that we're getting the right value. Let's try this out one more time. There we go. Started off as hello and became goodbye. Awesome. And just to show you that this is a unique piece of state, let's go and create a different one. And we'll call this one string two getter and setter. And we'll make that Jack. And then we'll console log that to start. And then console log that again at the end. And you'll see that there is no difference, right? So we don't actually set string setter to, and so it's still going to retain the same value as it had when we initially called that function. Okay.
I need coffee because I'm not getting this. So like this is straightforward. I mean, getter, setter, and of course if you see use state, that this is just like use state in React. That makes sense. So let me start from here, right? From a context that my brain understands, right? Simple string state, well, use state, right? Hello, getter, setter, right? String one, getter, string two, setter. Actually, string setter. Actually, let's just do this, dude. String setter. I just do this. String getter. I just spell it out, bro. String setter, string getter. String getter. String getter. It's not just do the thing. Right now, set string setter. Okay. Okay. String state. Simple string state. Just as a matter of fact, look. We're just gonna call you string state. So it's like use state, right? Go up here, we're gonna call you string state, right? Okay. Initial string. Okay, I can't read this the way this is. We'll try. So this is a function that receives an initial string state, like hello, right? And setter getter returns void. Let string. So yeah, so okay, so string initial. Okay, let's string initial with the value of string be initially this. Yeah, whatever was fed into it. Okay, so assign that to string type string. So str is a string, a type string. Return an arrow function that returns the string. I don't know what the v means, but that's the string from here, 18. Arrow function return string equals v. I don't like that. It's like this does not fit well in my head. That makes sense, getter and setter. But so this is what it's doing under the hood here. Why am I not understanding that? Okay. V string, void string. Turns void string? That doesn't make sense. Arrow function string returns void type string. I don't understand this single letter thing. Look, what is this? that a string? Or are we just saying that the string is a string? I know that single letter thing is a string. Okay, string, string, string. I don't like this. Closure, tuple. Tuples, tuples, tuples. I wonder if my favorite friends here loved that. That was great. Tuple. Do you have anything about tuples in here? Python tuples, TypeScript tuples. Okay. All right. Let's see if you guys can break this down to me a little bit better. Typed arrays. Tuple is a typed array with a predefined length and types for each index. Tuples are great because they allow each element in the array to be a known type of value. Oh wait, you know what? I didn't change the name of this thing. Watch me. Let's see. Go through here. Learning TypeScript tuples. TypeScript tuples. Okay, cool. So we'll do that like that. Okay, I had to change the name of this recording. Okay. Yeah, tuple is typed array, predefined length types for each index. Tuples are great because they allow each element in the array to be a known type of value. To define a tuple, specify the type of each element in the array. Let our tuple number Boolean string. Define our tuple. Let our tuple number Boolean string. Okay. Let's reread that. My mind is in my head. Tuple is a typed array with a predefined length and types for each index. Tuples are great because they allow each element in the array to be a known type of value. To define a tuple, specify the type of each element in the array. Types for each index. Tuples are great because they allow each element in the array to be a known type of value. To define a tuple, specify the type of each element in the array. Define a tuple, specify the type of each element in the array. Okay, define our tuple. Let our tuple be a number, Boolean, or string, right? Number, Boolean, or string. Okay. So let our tuple, see, that's what it should be. It should be something like, so yeah, because where is that? Function, add 3D coordinates. This is some other thing up here, right? Yeah, because that's dealing with this. Function 3D coordinates. Initialize correctly. Number, Boolean, string. Right. Let our tuple, and then tuple. Okay, so where is the tuple here? Is that this? The tuple contains strings. It's like, yeah, it should be named. The thing should be named. That makes sense. 3D coordinate, that's a tuple. And you're saying this is a number, and a number. Okay. And now we're using that tuple here. 3D coordinate, return C1, C2, C1, C2, C1, C2. Okay. Huh? Let's keep reading this version. Let our tuple number Boolean. Okay, this makes sense. As you can see, we have a number, Boolean, and a string. But what happens if we try to set them in the wrong order? Define our tuple. Yeah, see, I like this better. define our tuple. This tells me, because I'm looking at this like, what's the tuple? Where is the tuple? This, however, is nicer. This makes sense. Let our tuple be this, initialized correctly. As you can see, but what happens if we try to set them in the wrong order? Define our tuple, number Boolean string, number false. Well, let's find out. Let's go over here and check it out. It has a fit. Type Boolean is not assignable to, scooch over that. I say, yeah, type number. Boolean's right. It says, hey, these, okay, that makes sense. This is straightforward. That makes sense. I don't understand this. I get it. Yeah, okay, what? That's okay. How can I rewrite this to make this clearer? Let's go back. I go back. Oh, okay, I'm here. Okay, wait, close that. Okay, there we go. All right, that was distracted. That's something else. Okay, initialize correctly. Okay, so there's error. Even though we have a Boolean string of the order matters in our tuple, it will throw an error. So a tuple typed arrays. A tuple is a typed array with a predefined length and types for each index. Okay. Read-only tuple. A good practice is to make your tuple read-only. Tuples only have strongly defined types for the initial values. Strongly defined types for the initial values. Define our tuple. Let tuple, define our tuple. Let our tuple number, See, I like this because the naming tells you what the thing is that you're looking at, right? Let our tuple, right? Right. So who is the tuple here? Let string. So is that the tuple? This gets confusing. My frustration just wants to delete everything here. That's right. All right, so that's the first example. And then we do another example using the closure. No, use state is a tuple. Tuples with different types. Tuples with different types. Okay, so this up here is tuple example 1. Okay. That's this stuff up here. Go down here. Why does it not give me the green color? Note. Use state is a tuple. You define what that state is. Define states. Okay. I can see that. Let's see. Read only tuple. Tuples only have strongly defined types for the initial values. Define our tuple. Initialize correctly. Right. We have no type safety in our tuple for indexes over 3. Tuple at push, something new and wrong. Console log our tuple. Something new and wrong. Okay. Something new and wrong, huh? Oh, this is interesting. Why is this taking long to load? Something new and wrong. Okay, but I got added to the array. Okay. You see the new value tuples only have strongly defined types for the initial values. Define our read-only tuple. Constant, our read-only tuple. Read-only. Okay, wait. Do you need that keyword? Good practice is to make your tuple read-only. Number boolean string equals 5 true. The real. There was an error as it is read only. Huh. Interesting. That's nice. Okay. Okay. To learn more about access modifiers like read only, go to our section on them here, TypeScript classes. If you have ever used React before, you have worked with tuples more than likely. UState returns a tuple of the value and a setter function. Constant first name, set first name equals UState. Dylan is a common example. Right. Right. It's just like you just call it UState. It's like really. Uh-huh. String setter, string getter, string setter. Set first name. Right, getter, setter, right? String getter, string setter. Right, because of the structure, we know our first value in our list will be a certain value type, in this case, a string, and the second value, a function. Named tuples. Named tuples allow us to provide context for our values at each index. Example, constant graph, x number, y number equals 5. Oh, okay, graph, huh? Okay, wait, constant. My eyes trying to find constant. Did we set something as constant here? No, we did not. Type. This is very similar to this, but we have no chords. Here we create a function to add chords. We have a function to add chords. Name tuples provide more context for what our index values represent. Add coordinate function. Destructuring tuples. Since tuples are always arrays, excuse me, since tuples are arrays, we can also destructure. Okay, that tracks. XY equals graph, XY equals graph. This makes straightforward sense. This does not. Not understanding what the heck is going on here. Like, I understand this, and I understand this. Why do I not understand this guy going on in this closure? Right? This is a function that's going to receive first coordinate. And that first coordinate is going to be an array of 3 elements. That's chord 1. This is C1. And this is C2. Right? Add those coordinates. Returns 3D coordinate. Returns C1 plus C2 plus C1, C2, C1, C2. This part's confusing though. Like, what's going on here? What's this? C, right, because this was C plus 2, excuse me, C plus 2, and then C plus 2, C1, C2. Oh, I see. The commas, right? Yeah, it's because, yeah, that's because Prettier is helping me, right? Right. When my brain needs to see it like this, to clearly understand what's going on. It's like, I need Prettier to stop behaving. You turn Prettier off on file. Because it keeps doing this, and I'm like, what? Okay, C1, C2, yeah, no, this isn't about that. I need this to be this. Right, 0, 1, 2. First, second, third coordinate. First, second, 3D coordinate. Add 3D coordinates, C1, C2, 3D coordinate. Well, it takes two. Two takes two coordinates the three position. Right, okay. God, okay. String state. Yeah, I'm so stuck on what is being happening here. So this I like this better. Graph number equals this. So how can we rewrite this? Test yourself is the order of value types does not matter in tuples. False. Did you just say false? Submit answer false. Oh wait, what the heck? What the heck is this? False. Interesting. Okay. Experiment with something here. Oh, then there we go. Oh, then that's it. Okay, wait, this is more straightforward than this. Getter setter, but what the heck is going on here? This is so, I'm not getting it like this. Initial string. Okay, we got that. That kind of makes sense. That's amazing too. It does that here. Turn prettier off. Let's go back to Emacs. Let's go to Emacs and let's take a look. Let's take a look. Let's take a look. Is that here? Start stuff. Emacs. Emacs. Okay, turn prettier off. Don't see anything in there either way. That would kind of break that down. Turn prettier off for a particular file. Turn prettier off in a particular file. Let's see. Turn prettier off in a particular file. Turn prettier off in a particular file. Turn prettier off in a particular file. Okay, I'm gonna go ahead for this. Current file, current buffer. Are we still thinking about it? I don't want to stop you by some calling the text of the file I'm editing. Turn off pretty. Okay. Prettier mode enable. Turn prettier off. You turn a particular mode off. Turn off prompt. Turn prettier. Turn pretty off. That's aggravating right now. What do you mean you don't use the global install of prettier, but a local one appears so prettier or yarn app project? Check that local versus prettier available. Maybe how do you turn pretty? How do I turn you off? You're driving me nuts. Blah 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 blah. Double truncated lines. Okay. Nope. It's gotta be prettier, right? Still like a, where you at? Okay, so is there a toggle? Does know what that is. It doesn't know what that is. It doesn't know what that is. Okay. Right. Let's do this. Lovely. Okay, so let's go see this. Turn it off. 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 You know, sitting here like this, I don't know. I should probably have some background music, right? Music, background music, background. Hang on. Music. Cheat codes. Okay. Eeny, meeny, miny, mo. I like the art here. This art's dope. But I know this music most likely. So let's peep. Let's do that. Here we go. A little background music as we're hunting this down. Okay, Prettier.js for Emacs. Let me turn this puppy off, man. Which prettier? Require add hook, blah blah blah. Pretty hours to adjust. Set the arguments, blah blah blah. Using with web mode, blah blah blah. Add hook. Show errors. Width mode. Customize the width when formatting buffer contents. Customize where to display the error. Are the args passed? Prettier command. Is prettier command. Okay. Command. Customize group. Okay. Oh my god. Okay. No idea how to turn this off. Eating up time trying to figure it out. Alright. That's gonna be a different mission. I'm like, what? I'm not digging this. I'm not digging this particular explanation because what is this? It just looks like a stack of letters stacked on top of each other. And it's not his fault. It's because of freaking prettier right now getting in the way of my brain understanding the shape of this code. Right. So we got this initial string state. Okay. String state. That node doesn't have to go there. So tuples with different types. Tuples with different types. String. Void. Return an array that contains it's like what am I looking at, bro? I don't know, it like this should be just super clear, right? But it's not in my head right now. State. Oh boy. Yeah. This does not need to be open right now. This crap. Boy, oh boy. Maybe. Login. I don't remember who I logged in with. Oh my god. Okay. Alright, that. Off screen. Man, I'm not digging it, bro. Hang on, let me try this again. Let me just start again.
Tuples, define what they are, and then show how to implement on them, and show some common implementations that you might see out there in the wild. All right, let's get right into it. So the first thing I'm going to do is create another file called tuples. And I'm going to make what most people would consider the kind of canonical tuple, at least in the documentation, and that is a 3D coordinate. So I'm going to define a type of 3D coordinate.
And see, he's got type.
And then I'm going to define
But they never use type here. They're like, yo, a tuple is this. Right? So what's with this keyword type? What's with the keyword type? Where's TypeScript? Where's my TypeScript thing? There we go. TypeScript, get started. TypeScript, okay. So wait. Can you tell, is there a search thing here, man? Handbook, reference, maybe tutorial. Okay, yeah, that's nothing. Reference, tuple. Okay, search, bruh. Search docs, right? Please break this down to me. Tuple, not tuple destructuring. Show me what a tuple is. Tuples, which are fixed lengths but mutable. Built-in types. Okay, TypeScript. Okay, functional. Other important TypeScript types. Getting started. Tuples. All right. Other important TypeScript types. Type isolation. Unknown. Never. Blah blah blah. T. Mutable arrays. Also written array T. Does that mean tuple? TT. Tuples, which are fixed length but mutable. TT functions. Whatever. What is that? Okay. Okay. Notes. Function syntax includes parameters. Blah 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 blah. TT. Okay, so that's unknown. TT. Okay. Object literal type syntax closely mirrors object literal value syntax. TT is a subtype of T. This is different from Haskell where tuples are not. I don't care about Haskell. Why are you talking about Haskell? Move on. Box types. JavaScript has a box equivalent of primitive types that contain the methods that program associated with those types. TypeScript reflects Example, blah, 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 blah. Gradual typing. Where did this come from? Gradual typing. Array.maps. That's sepsis. Yeah, sepsis for real. Structure typing. Okay. Here they're using type. Okay. Here the object literal, blah, 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 blah. Names, blah, 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 blah. Below 2. Okay. Name types just give a name to a type for assignability. This is a named type. Okay. Assignability purposes. There is no difference between the type alias 1 and the interface type 2 below. And the interface. Oh, there's no difference. That's what this is. Okay. They both have a property p string. Type aliases behave differently from interfaces with respect to recursive definitions and type parameters, however. Oh, so this is the same thing. Okay. Then wait. They both have the type aliases behave differently from interfaces. Then they're not the same thing. If it behaves differently, it's not the same thing. Right? So wouldn't it be better to rewrite this a little bit differently? TypeScript union types tagged. In other words, they are not discriminated unions like data, type of our string array and function. Note that functions and arrays are objects, runtime intersections, blah 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 blah. Okay, so now at least I know where that type, where this keyword comes from. Type. Okay. Let's go back. Where was he? Okay, there we go.
This as a tuple, and a tuple is an array. So I'm going to start with an array, and then each value in there is given a name and a type. So X is going to be a number, Y is going to be a number, and then Z is going to be a number. So in this case, all of them are the same number, but in tuples, each particular item in that array can be any type you want, and we'll see that in just a second. Okay, so let's actually implement on this and show you how it works. So I'm going to create a function that adds two 3D coordinates together.
Okay. This, and then we do that. Wait, isn't that supposed to take you back to the front? Nope. Okay, no. How do I escape out of that? So, I keep wanting to do this. Oh, that is it. Okay.
So it's going to take C1, which would be a 3D coordinate, and then C2, which is also a 3D coordinate, and then it's going to return a 3D coordinate. And with that, I'm just going to take C1 at 0 and add it to C2 at 0. Copy and paste that 2 more times. Change this to a 1, that to a 2. This to a 1, that to a 2, and we should be good. So let's console that out and give it a try. And we just specify it using an array. So let's say 0, 0, 0, and add it to 10, 20, 30. See how that goes. All right. Let's do npx_ts node, and then do tuples. See how we go. All right, 10, 20, 30. Let's make sure we got the right order. So just change out that origin point or whatever. Yeah, looking pretty good. Okay, great. But if you're a React engineer, you actually probably deal with one particular tuple all the time, and that's the useState tuple. So useState returns a state and then a state setter. Let's go and implement our own simple string state that does something similar. So it's going to take an initial value, which is a string, and then it's going to return a tuple.
Wait,
and that
go
tuple,
back.
singular, good. Okay, great. All right, so let's say 0, 0, 0, and add it to 10, 20, 30. Let's see how that goes. All right. Let's do npx ts node, and then do tuples. See how we go. All right, 10, 20, 30. Let's make sure we got the right order. So just change out that origin point or whatever. Yeah, looking pretty good. Okay, great. But
defining the type, that's the tuple right there. So that's the tuple, and now you're doing a function that adds two 3D chords together. Find a type. This is the tuple. Containing name type.
Come on,
Right, like
let's do this now.
this is that's the tuple right there. Right? So now we just got a function that's using the tuple. Now we got a function that adds two chords together. It's fantastic. That doesn't really matter. But that's the tuple right there. This is just a tuple right here. This is our tuple, right? Now we're going to implement. Now we're going to use this tuple in a function. Use this tuple and a function that adds two 3D chords together. Fantastic. Now, two that adds two 3D chords together. Yeah, three chord. One. Yeah. Two 3D chords together, and then output their elements as such. Right. Boom, boom, boom. Okay, that tracks. Now. So that's really it. Now, but then we go into this other bag of cats. Okay, so now we got a fancy closure, right? We're gonna use a closure that sets the value of the string, that gets a new value of the string from the setter, right? And then we do a getter setter. So like demoing what useState does. Okay, I mean that's that. That's just okay. But this typed arrays tuples, this is a bit better. Initialize correctly, define our tuple, let our tuple do this, right? Initialize correctly, right? The fact that they have to be a particular thing in order like that is a detail that's missing from his thing over there. So like that's important. So if I was to do that, I was going to say something like this. Hey, Mio. So I don't know why it keeps doing that at the end point here. Let's come up here and can't seem to get you Lisp, and this thing exceeds verbal. What you doing? Let's see. How can I trick you? Well, actually, we could do something like this. Paste, right, and then that. Initialize correctly. Find our tuple. Tuple good because they allow each element in the array types predefined length. Okay, yeah, let's get this. This is the deal. Tuple. Oops, paste. A tuple is a typed array with a predefined length and types for each index. Find our tuple. So then we go here. I hit this. Add up. Yeah, define our tuple. Our tuple. Right. Initialize correctly. Boom. Right. Put them in the wrong order. This is important. I'll pop that over here. Type. This is our tuple. Paste. But what happens if, see, what would be neat if I could just pop up here and then just pop over to that B, right? That capital B. Word. Okay, that's this. Wrong order. If we did that in the wrong order, oops. We did that in the wrong order. And we did something like this. Copy. Let's go here. Let's put that back on. Paste. And it doesn't even let us. It's like it knows that already. It's like, hey, our tuple. Wait. Oh, actually, we already got that. So let me do this. It's an error, right? It's like, what? Reset that. Now it's like, no. It tells you keyword is wrong. That's why you get the red. Right. That's better. This is clear. Yeah. That's what a tuple is. First, let's talk about it. Now let's implement it. Tuple. Let's implement it. Yeah, this would be cool if you had like 3 things of different types, right? You had to force those types, blah, 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 yada, yada, yada. Or if you try to pass in something that wasn't a string here, I could tell this thing this had to be a string, but, well, I would still receive that, right? But does it know that that's a string? Like if I passed, because this would be a nice little thing to say, like, 30, right? Like that argument of type number is not assignable to parameter type string, right? So it's telling it that it has to be a freaking string, right? Okay, cool. So, oh wait, so we want to say, oh, there we go. Okay. Let's see, read only. Let's see. Let's see. Okay, so let's think about this next part here. Okay, so that's cool. We got that example. We can kind kind of see what's happening there to understand this concept. Oh yeah. And then type, right? So yeah, type. Because he's using type, so we gotta wait. Where is let's go grab that again. So was that in here? Was this page? Yeah. That's the other thing, right? Yeah, so alright. So yeah, named types just give a name to a type for assignability purposes. There's no difference between the type alias 1 and the interface type 2 below. They both have a property. Type aliases behave differently from interfaces with respect to recursive definitions and type parameters. So this is a type alias. Type alias. Okay. Type alias. A type alias. Oh wait, type aliases. Wait a minute. It's all the way down here. Type aliases are mere aliases, just like, oh my god, I want to scream. Why is this in the documentation? Just like type in Haskell, because obviously everybody who's a JavaScript developer has also been writing Haskell code, so they completely get the context when we mention Haskell. Oh my god. I'm sorry, why is this in the documentation? Oh my god, bro. What? Why is this here? Strip references to Haskell out of the official documentation for TypeScript. Why is this? Why are you referencing some other? Oh man. Okay. All right. Let me be nice. Let me be kind, because that makes no sense. I don't understand why that's there. Okay. Type aliases are mere aliases. The compiler will attempt to use the alias name wherever it was used in the source code. It does not always succeed. Okay, term, type, let's implement it. Type, 3 chords. Okay, why? Why are we using the thing? Because what does that do? Okay. Hang on. Why does this not highlight? Nope, abs. Okay, to do, there we go. Note. To do, note. Type aliases. Note. Terminology. I'm not sure if I'm spelling that right. Terminology. Type. Aliases. Type aliases. Type. Let's see. Actually, let's see. Type refers to type aliases. Refers to type aliases. Okay, the compiler. Copy that. Paste that. And bring that over. Okay. The compiler will attempt to use the alias name wherever it was used in the source code, but does not always succeed. Okay, so we're using that kind of. Why are we saying types? Type size is number. Let x size. Dot. The closest equivalent to new type is a tagged intersection. Type f string. Looks at any. Okay. Type f string. Okay, string. All that. F string is just like normal string, except that the compiler thinks it has a property named compile time only that doesn't actually exist. This means that f string can still be assigned to string, but not the other way around. Discriminated unions. The closest equivalent to data is a union of types with discriminant properties, normally called discriminant unions in TypeScript. Type shape. Radius, number, kind, circle, blah, 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 blah. Type shape. Man, they are really pissing me off with all these references to, you know, right now is where I would go to Twitter if I cared to be on Twitter. I just, oh my God, no. Thanks for the feedback. Look, where, I want to scream. Contributors to this page, some clown who's a Haskell developer that wants everybody to learn Haskell. F off with shoving stuff down people's throats, bro. Let's see. Oh man, I just want to be. I'm so like, why? Oh wait. Can I edit this? I will spend a weekend, I'll spend a month stripping all these references to Haskell out. Can I edit this? Where is this? Like, why is that in the documentation? And who's merging it? Okay, wait. Wait. Is this the documentation? Wait. Okay, that's TypeScript. Okay, it's TypeScript. Wait. Docs. Wait. Okay, wait. No, that's the, okay, no. God, I do not care to be on web repo, website repo. Docs. Deprecating. Something wrong. Okay, that's a quest to discover, because if this documentation is online and I can put pull requests, and I'm going to go. Oh man, yeah. I would spend time in my life cleaning that nonsense up. Stop referring to a different language. Oh my God. Point free programming. Let's go. Type parameters. Discriminated unions. Closest equivalent to data is a union of types with discriminant properties, normally called discriminant unions in TypeScript. Type. Okay. Data is type shape. Please shut up with this nonsense. You can discriminate members of the union using blah 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 blah. Note that the return of blah 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 blah. Also, unlike Haskell, common properties. Oh man, this is pissing me. Okay, you know what? This is so disturbing my zen. I'm going to have to just get out of it. I need a new reference that does not refer to freaking. God, Haskell, you can't. Made with the Redmond bosses as Microsoft. Community, get help. Yeah, get help. Yeah, you know what? Okay, that's an option. I'm gonna have to dig this when I'm not hot, because right now I'm like, man, bro, what the hell is this nonsense? Come out of here. But this is interesting in that we can at least say what this is. No terminology type refers to type aliases. The compiler will attempt to use the alias name wherever it was used in the source code, but that does not always succeed. Why? So you do double quotes. I type in one quote, I want one quote. Stop helping me. Getting in the way. Compiler will attempt to do okay. And like this is just another level of why I need to do this. I just can't say, you know, like let 3 chords be this, da 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 da. Because why are you doing that, you know? And was that something in one of the early videos that it's been like a week that I just didn't catch? Right? Optionals, challenge, function overloading, functions, everyday types. Like, was there something that I missed earlier? God, okay. So,
But if you're a React engineer, you actually probably deal with
tuples with different types. I'm not going to review that part again. I'm kind of curious to find out, was there something in an earlier part relating to type to this keyword that he put in a different video? And now I'm like, do I want to go hunt that down in the previous videos? Or should I end this video here? Because I'm not satisfied with this. Right? Like, why is that being used here like this? We know what this is. We can look that up here. See, because like here we've got a tuple like this, right? But here we're doing a tuple like this. Initialized correctly. We're saying we're kind of merging those two things together, right? Simple types. Explicit. Where did this implicit type? Let's see. Do we use type in here like that? Exercise. Okay. Special types. Type any. Okay. Let's see. Let u equals true equals string. Okay, let v equals any equals true, right? String, method, right? Okay. Any, v string, right? That's v string. Type unknown, right? Unknown. W unknown. X never. Undefined. Nope. Raise tuples. Simple types, special types, simple types. Oh, we just got through with simple types, didn't we? But yeah, we did. Raise. We got a raise, right, and then tuples, right. But where do they use type, right? Object types. Car, type, inference types. We can infer the types of properties based on their values. Car, the type, optional properties. Car, new age map. Oh wait, go back. Did I see everything? No, I did. Okay. Type inference, car, type total, that type. Okay, blah 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 blah. TypeScript exercise. Enums. Oh boy. Okay. Status. Yeah. Aliases. Let's keep going. Yada yada yada. Okay. Still don't see union types. This might be the way to go, really. Functions. Right, because where did that come from? Type, and then, let's see, okay, we see that, but let's see, it's not clear. Parameters, because the concept of tuples is straightforward. I mean, that makes sense. But we're not talking about tuples here when you're adding extra terminology like type. But like, did he break that down before? Because I don't think he mentioned type before. Nope, we didn't do optionals. Wasn't in the challenge. Overloading everyday types. God, let me go back. Let me go look at this real quick.
Welcome to No BS TS.
Welcome to No
So
BS
growing
TS.
speed,
All right, Jack,
you try
let's see
to
what you got. Let's go
today.
here. We're gonna go look at this.
Okay, now let's start
I'm
off.
gonna just jump
And of course, I
around
wanna-
here because really, I
We
just
can
want to
see
see
that.
you
And of course,
use
how do we get Tyler?
that keyword,
C,
right?
which is the name of the
Do
type
you
group.
use the
In fact, we can see over
keyword?
here. because I can do command
Type.
typing for you.
And
It's
any of
also
this, actually, hang on, I'm just gonna quiet that down because I'm trying to hunt for the use of the keyword type. Where is that keyword introduced in the little videos here, the tutorials? Let's see, do we mention that anywhere early on? I don't see that here, not in the first one. Okay, no, okay, and then the outro is the outro. Right, okay, let's go to the next one. Number 2, functions. All right, let's go see these functions. Do we see the keyword type being used anywhere in the stuff here? Let's see, do we see that anywhere in the code? Do we see it anywhere in the code? Let's see. Let's go back. Let's go back here. Let's go back. Let's go back. Let's go back. Let's don't see it. I don't see it. Do you see it? I don't see it. I don't see it. So not there. Okay, where do we use type in here? Because that's not explained as to what that keyword is doing in this lesson. So I don't think that should be used in this lesson because it's too disorienting. It's disorienting up here in the quote-unquote simple part, and then all this happens down here, and you're like, what's going on? I'm like, you get lost. Okay, so nope. Functions as types. Function as a type of thing, right? Oh, look, there we go. Here we go. Mutation function. What's this? Functions as type. Oh, okay. Wait. What? Okay, wait. Hang on. Let's get this on.
potential type specification that you can share with other things. So I'm going to grab this, copy it, and then create a new one called type mutation function. And then in this case, unlike interface, you have to use equals and then paste that.
Okay,
and
wait,
there
does
you
he
go.
talk about
A
it?
mutation function that takes an array of numbers.
Does he get over where that type keyword comes from?
And then it's going to take a function that is given each number and returns a new number. So for example, I'll mutate, it's going to be a function. It's going to take a number and it's going to return a number. And this function is going to return a set of numbers on its own. And now how do we do this? Well, honestly, this is just map. So let's just do numbers.map and then give it that mutate function. All right, let's give it a try here. Console.log. We'll give it our array mutate. We'll give it an array of 1, 2, and 3. And let's see. So it's automatically hinting us that we need a function here, and that function takes a number and it returns a number. So let's do that. And let's just multiply it by 10. Okay, let's run it in console log. Again, we'll use TS node, and we're calling this one funcs and funcs. And there you go. 1, 2, 3 becomes 10, 20, 30. Change that 20 there. Run it again. 10, 230. Excellent. Cool. But this is a little bit hard to read, at least.
Yeah, really? That's why we doing that over here before with V and whatnot. Oh my god. Okay.
For me. So I'm going to define this as a type. Now, anything that is after that colon is a potential type specification that you can share with other things. So I'm going to grab this, copy it, and then create a new one called type mutation function. And then in this case, unlike interface, you have to use equals and then paste that. And there you go. Now copy that and paste that in there. And I think that just reads a little nicer. Now you can also, if you like, you can export this mutation function as well. And that way, when somebody's creating a function, let's go here and create a potential mutation function. So my new mutate function, and it'll just give it the type of mutation function. And it doesn't qualify yet because I haven't implemented it. So let's go over here and we're gonna say we want a value, and that value is a string, and then it's gonna return a string, and there you go. And it's like, wait a second, hold up. That's not right, because the type of a function that takes a string and returns a string is not assignable to a type mutation function. All right, which is very true. So this needs to be a number, which is still not right because now we're.
You get into that? Okay, so. Functions, casting. Okay, so he does mention that keyword, or do we get into what that's doing? Where, right? Private parameter, yada yada yada, yada 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 yada, classes, overriding classes, abstract, basic generics, basic generics. Oh, there we go. Type aliases. Whoo! Basic generics. Huh, wow, this size around PHP. Look at that. Can you imagine? I should have stuck with PHP freaking 20 years ago. Generics and type aliases allow creating types that are more reusable. Example, type wrapped. Okay, generics and type aliases allow creating types that are more reusable. Okay. Oh shoot, I forgot that was going on today. Oh man. Okay, wait. Oh shoot, what the frack? 3 hours ago. Oh my god. Oh, that started. Okay, oh shoot. Okay. Alright, I am gonna dig into this some more, but I gotta stop the vid. Well, I gotta stop this stream and go on to something else. Something else that I gotta go peep. So I'm gonna stop this. Transition out of this. So until next time, I'm gonna keep digging into type because there's got to be a better way of explaining tuple. But now I see where type is coming from. Yeah, I think that example is a bit much though. Then we get into tuples with different types. I'm like, do I care about that? I'm just trying to get over the concept of tuples, but I'm like, getters and set. What you get the use state thing? That's kind of cool. Anyway, I'm talking too much. We need a simpler breakdown of tuples for a beginner. To really understand what's going on in this code here. All right. Anyway, so that's it for now. Till next time. Later.